Hi, this is Julian from Digital Pebble. In this tutorial I will show you how to use StormCrawler with Apache SOLR. There's already a couple of tutorials on how to use StormCrawler and Elasticsearch, but this one will be focused on SOLR. You'll find it's very similar compared to Elasticsearch in the way we use it. So we need the version 7.40 of SOLR, which is the current one at the moment, and we'll use StormCrawler 1.10. So first we'll create a project for StormCrawler using the archetype. So I'll go in the temp directory and use the StormCrawler archetype version 1.10. And that will create a basic set of resources for StormCrawler, so configuration, classes, and so on. So group ID, I'll just put DP for Digital Pebble. Artifact, we'll call that SOLR demo. Version, that's fine. Package, that's fine. Yes. And now let's have a look at the content of that SOLR demo directory that we just created. So we have a readme, a POM file for Maven to manage the dependencies and stuff, a default configuration file which defines some of the stuff that StormCrawler will do, the agent name and so on. So again, that's as usual, this is the starting point. You should customize these files as needed. And then in the source there's just there's two things. There's a set of resources for the filters and the parsed filters, URL filters. Again, you can have a look at the other tutorials to have a better explanation of these things. In this one I'll just focus on the SOLR side of things, and a class which defines here a default topology. We'll probably be using Flux, so we won't be building the topology from using the Java class. So the first thing to do is, since we'll be using SOLR, is to add the SOLR module of StormCrawler as a dependency. And it's basically as simple as doing this, adding the SOLR dependency to Maven. Right, that was a good start. Now what we want to do, and I'll look into the source code of StormCrawler. So it's just the master branch as it stands. And let's have a quick look at the external module for SOLR. So there's some code for the components that are for communicating with SOLR. So we have a default topology, which will be very similar to the one generated by the archetype. We will not use this class. Another topology that just does seed injection. A bolt to index the documents that are crawled and parsed and everything, and that we might want to query to index that into a SOLR index. A similar thing, but to index the metrics generated by Storm into SOLR. And then later on you could use a tool like Grafana. At the moment I don't think it has a connector for SOLR, but it might in the future. So you might be able to read from the SOLR index and display the graphs. And finally, two components for persisting the information about the URLs into a SOLR index. So these are the when we called that added that Maven dependency, it added all these Java classes to our class path, so we don't need to, we can use them in our topology straight away. The other thing we're getting here, we're getting two more things. We're getting a set of configuration, a configuration file containing resources for SOLR. So I'll paste it here and we'll have a quick look. And it basically tells us where the SOLR indices live and so on. So these are the default values and they're fine. It also creates defines a metrics consumer so that for SOLR, so that sorry, for Storm, so that Storm will send its metrics to that class that we've just seen. And the last bit we need is from there is a set of definitions for the various calls. So basically our indices. And what I'll do, that's for a previous run, I'll delete the data bit. So if you look at the content of StormCrawler on GitHub, for instance, or you check it out on Git, you will see something that looks like that. So we'll keep the names here of that directory, and we can start. We'll start SOLR, and we'll give it just those definitions of the calls. So that should be the command, if I'm not mistaken. That's right. And we will give it so S and then SOLR home property. So let's try that. And now what I'll do is I'll use not that. I'll use that's it. So we can see that the calls have been loaded. So we have the docs, metrics, status. So basically docs is again crawl, documents, parsed, and so on. So typically you want to build a search engine, that's where your documents will be that you'll be querying against. Metrics is for again having a look at the behavior and being able to monitor the behavior of StormCrawler. You don't have to use that. You don't have to use the metrics. And finally, status is for storing the information about the URLs. Again, you can mix and match. You could just index the documents, not the metrics, and have the status stored somewhere else, say in a queue and so on. You can mix the various components. Status here is just if we want to use SOLR as a backend for the information. Right, so everything's up and running. That's great. Now, what do we need to do? We need to have a look at the so I said we'll use the flux file for the configuration. So first step, we need to tell flux to use to load that SOLR-conf YAML. And here by default it's very basic. It just loads it just sends URLs down the topology, and here the basic topology coming from the archetype just fetches the URLs, passes them, does a dummy indexing on the console, and dumps the status on the console. We don't want to do that. We want to index to SOLR. So let's have a quick look to check the names of the classes. So we want the indexer, which is under StormCrawler SOLR, and it's called bolt indexer bolt. So it's SOLR bolt indexer bolt, and then these URLs we just want to store their status in SOLR, and also add the newly discovered URLs to SOLR as well. Of course, in real life you would probably inject your seeds first in a separate topology or as part of the same topology, and later on I'll show you how to use a spout that will, instead of reading from the URLs we set here in the memory spout, but instead later on we'll read from Storm. So here it's just a demo. Again, you'd probably have two processes, one for first injection of the seeds and then a topology that will be running continuously and pull the information from Solr. So the second thing we need is persistence for the URLs, and that is under Solr persistence status updater bolt. So status updater bolt. Right, that looks okay. I've already forgotten something, but if that's the case, it's no big deal, we'll fix it. Okay, so I have my crawler flux, should be okay. So first we will go back here, and what we'll do in this one is we'll call Maven clean package to build all the dependencies and build a new jar. If you look at all these steps are explained in the README, so it tells you what to do. This command here would be used if we had modified the Java class to define the topology, but we modified Flux, so we won't use that. We'll use the following one here. Let's have a look. Okay, so it's been built. Let's try. So we should see a few URLs being processed, and then we'll have a look at the Solr indices and see what they contain. So it's running here. It's running in local mode, so you don't need to have installed Storm, on your machine. Yeah, that's fine. So okay, so it's processed, it's fetched and parsed few URLs. It can't do some of them, like liquid.fr, because of the crawl delay. And that's it. So now let's have a look at the quick look at the Solr admin. So docs, yeah, it has index 2 docs. Metrics, yeah, it generated a few metrics. You can see 45 of them. And status. Let's have a look at status. If we go on query, we can have a look and see how the information is stored in Solr. Yeah, so we can see the URL, host, status. These are redirections. Next fetch date, and so on. And some of them, like discovered, means we haven't fetched them, but we just found them from this page, Storm Apache org. So far so good. We can kill this one because it has nothing to do. It has fetched all the things that the memory spout had sent down the topology. So now what we want to do is to, instead of using the memory spout, we will use the one that connects to Solr. So we'll use the Solr spout, and the default configuration we had here should do the trick. It should work fine. So let's try again. I need this one. So we'll restart the crawl from Flux in local mode. Yes, that's because I used the wrong class name. So it's Solr persistence. Yeah, that should be better. Let's try again. Right, this time you can see, again, we're using in local mode, so it's dumping everything to the console. If we were using it in deployed mode with Storm properly installed and running, with its various services running and so on, things would be dumped to the logs instead of going to the console. But for testing and everything, the local mode's absolutely fine. As a matter of fact, you can, it's pretty easy to run, even to run it in Eclipse. With the topology class, if you want to debug stuff and so on. So you can see it's yeah, fetching and parsing all these URLs. So that's it. We are crawling the web with SOLR as a backend. So if we look at the our status, you can see it has fetched some stuff. There's probably a way of filtering only by status and so on, as you do with when using Kibana, for instance. Great, so it's storing all these things in the status. Metrics, we can have a quick look at the metrics, see what they look like. Again, it makes sense to use them with something like Grafana, or and it's basically yeah, they all have these fields, and you can use them to track how fast the crawler is going, and so on. Finally, we'll have a quick look at the docs. And these are the documents that we parse and fetch and parse and index. And the fields here are the default fields generated by the topology from the archetype. This is one of the advantages of StormCrawler, is that it's pretty easy to customize. So you can customize all these fields. You can add new things, new like keywords. Well, we do have the keywords here, but new fields for the documents based on whatever extraction you want to do. You can add language and for instance, and so on. So that's it. I think I've covered it all. I hope you enjoy this tutorial, and happy crawling. Have fun.